Hello students, welcome to my session. Myself is Vanaja, lecturer in physics from Government Polytechnic, Nirmal. In this session, I am going to explain the formation of depletion layer, the PN diode, forward bias and reverse bias. First of all, the formation of the depletion layer in PN junction. So how the PN junction is formed? A piece of p-type semiconductor joined to the piece of n-type semiconductor in such a manner that the crystal structure remains continuous at the boundary. Then the PN junction is formed. So when p-type semiconductor is joined with the piece of n-type semiconductor and at the boundary there is the crystal structure remains continuous at the boundary, and this is called the PN junction. So in the p-type semiconductor means the trivalent impurity is added to the pure semiconductor is the p-type, and the pentavalent impurity is added to the pure semiconductor is called n-type, and these two are joined such that there is it is a continuous, the crystal structure is continuous at the boundary, is called the PN junction. So this is the circuit symbol and the physical structure, the physical model of the PN junction. So observe the slide, students, the circuit diagram of the PN diode and the physical structure of the PN junction and the physical model, that is P and N regions, you can see in the slide. So these will be the symbol and structure models of the PN junction. Now the formation of depletion layer. How the depletion layer is formed? When P type of semiconductor is joined with the N-type semiconductor. Actually, the P region contains holes as majority carriers, electrons as minority charge carriers, and there will be some acceptor ions. So the acceptor ions are negative charged immobile ions. The P region contains, see the slide, students, p-type n-type is joined inside and at the junction, so see the white spheres, so white dots is there, and that will be hole, and orange color symbol is there, dot is there, that is the electron. So holes are the majority charge carriers, electrons are the minority charge carriers, and there is the acceptor ions, these are the negatively charged immobile ions in the P region. Whereas in N region, electrons are the majority charge carriers and holes are the minority charge carriers, and in this there are donor ions, means positively charged immobile ions. Therefore the whole sample is neutral. Here the complete sample is neutral, and the whole donor ions are the positively charged immobile ions. So these are the charge carriers, majority minority charge carrier and ions in the P region and as well as in N region. Now when no voltage is applied to the PN junction, just we joined the P type semiconductor to N-type semiconductor, then the PN junction is formed, and there will be some actions takes place. What are the actions takes place when P-type is joined to the N-type semiconductor? When P region is connected to N region, As we know, holes are the majority charge carriers in the p region. These holes are diffused towards the n region and they combine with the electrons in the n region. In the same way, electrons in the n region diffuse towards the p region and combine with the holes in the p region. Do you understand? Here, the holes moving towards the junction, crossing the junction and recombine with the electrons in the n region, and whereas the electrons in the n region crossing the junction and moving towards the p region and combine with the holes in the p region. P region has more number of holes and n region has more number of electrons. Therefore, there is a difference of concentration in two regions. There is a concentration difference in two regions. Due to this difference, the diffusion of holes and electrons takes place. Due to difference in the concentration of the two regions, the diffusion of holes and the diffusion of electrons takes place across the junction. And the electrons and holes move at random in all the directions because of the thermal energy. Because of the thermal energy, these electrons and holes move randomly throughout the crystal and because of the thermal energy. And some charge carriers may cross the junction also. So, this diffusion of holes from p region to n region and the electrons from n to p region continues for a short period of time. For a short period of time. What happens after some recombinations takes place? The recombination of electron hole and means the whole electrons recombination. So there will be some opposing force set up atomically in the neighborhood of the junction after few recombinations of electrons and holes. Why the opposing force is set up at the junction? This opposing force is called as barrier. This opposing force is called as barrier. The formation of the barrier is formed like this. As the p-n junction is formed, some holes in the p region and some electrons in the n region diffusing in each other and recombine. Means holes from p type cross the junction and recombine with the holes electrons in the n region, and electrons in the n region cross the junction and recombine with the holes, and some recombinations takes place. After some few recombinations, there is a opposing force is created at the junction. Okay, and this recombination eliminates a hole and a free electron. This recombination eliminates a hole and as well as a free electron. So therefore, the negative acceptor ions in the p region means in the p region the electrons from n region crossing the junction and recombine with the holes in the p region. So therefore, the electrons are absorbed by the p region. So therefore, positive ions, positive donor ions created in the n region. And the negative acceptor ions are created in the P region. Negative acceptor ions in the P region and positive donor ions are created in the N region after few recombinations. So, holes trying to, suppose after formation of acceptor ions in the P region and positively charged donor ions in the N region, suppose if some holes, again some holes in the P region diffuse into N region, tries to diffuse towards the N region, what happens? So observe here, if a hole in the P region tries to cross the junction, that hole is actually positively charged carrier, charge carrier. So this positively charged carrier will be repelled by the donor ions in the N region as well as attracted by the acceptor ions in the P region. The holes are repelled by the positively charged immobile ions in the N region. In the same way, if the electron diffuse towards the P region, these electrons are repelled by negatively charged acceptor ions in P region. So, due to this, the further diffusion and further recombinations will be stopped. The further diffusion of holes and electrons across the junction will be stopped. So, this region having compensated acceptor and donor ions only. This region consists of only acceptor and donor ions. There is no charge carrier in the near the junction. There is no charge carrier near the junction, means holes are repelled for the diffusion as well as electrons also repelled for the diffusion. No more charge carrier is accepting. They are repelled across the junction due to acceptor and donor ions existing in the across the junction. So, this region is also called as depletion layer. Why? Because there is depletion of charge carrier is existing. There is no more charge carrier across the junction, and also it is called as space charge region. And the width of the depletion layer actually depends on the doping level of impurity in N-type and P-type semiconductor. The width of the depletion layer depends on the doping level of impurity in N-type and P-type semiconductor. The greater the doping level, the depletion layer will be thinner. If lesser the doping level, the depletion layer will be thicker. It is wider. Now the potential barrier for a PN junction. So, the electric field between the acceptor and the donor ions is called barrier. How the electric field is generated here? We know that acceptor ions are negatively charged and donor ions are positively charged ions. So between these two ions, the electric field will be generated and is called as barrier. And the width of the barrier is the physical distance from one side of the barrier to the other side. And the height of the barrier is nothing but the difference of potential from one side of the barrier to the other side. So the width of the barrier is the physical distance from one side of the barrier to other side, and the height of the barrier is the difference of potential from one side of the barrier to other side. Now the biasing of the PN junction. Biasing of PN junction. When we apply a battery across the PN junction, this process is called as biasing the PN junction. Means we are connecting the battery to the PN junction. It's called as biasing of PN junction. And the width of the depletion layer can be controlled by applying the external voltage across the junction. That means the width of the depletion layer will be either increases or decreases and decided by the external voltage applied across the junction. And there are two types of biasing methods. One is forward bias, another one is reverse bias. First of all, what is meant by forward bias? The PN junction under forward bias. So the positive terminal of the battery is connected to P side and the negative terminal of the battery is connected to N side. Positive terminal is connected to P region and negative terminal is connected to N region. So it is called as PN junction. Therefore, as the P region consists of holes and N region consists of electrons, when battery is connected, these holes in P regions are repelled by the battery, positive terminal of the battery, and electrons are repelled by the negative terminal of the battery. So these holes in P side and electrons in the N side will be moved or forced towards the junction. So they are repelled by the positive holes, repelled by positive terminal, electrons repelled by the negative terminal of the battery and moving towards the junction. Then these electrons and holes are trying to cross the junction. Now because of this increased energy, means we are connecting some voltage externally, some holes and electrons enter into the depletion region. Actually, the depletion layer is depleted of charge carriers. There exist only immobile positive and negative ions. But due to repulsion of the holes in the P side from the positive terminal of the battery and electrons in the N side repelled by the negative terminal of the battery, they are forced to move towards the junction and they are entering into the depletion layer. So automatically the width of the depletion layer is decreases. So nothing but the opposition for movement of the charge carriers is decreases. Opposition is nothing but resistance. Opposition for the flow of charge carriers is nothing but resistance. So the width of the barrier is decreases, nothing but the resistance of the device decreases in the forward bias. And for each recombination of free electron and hole, an electron from the negative terminal of the battery enters into the N region and moves towards the junction. And in the P region, near the positive terminal of the battery, an electron breaks the bond in the crystal structures and enters the positive terminal of the battery. So here, for each recombination, the electron from the negative terminal of the battery enters the N region. In the same way, in the P region, an electron breaks the bond in the crystal and enters the positive terminal of the battery. So this completes one total circuits. And for each electron which breaks its bond, a hole is created. So that hole in the P region will be moved towards the junction. So the current through the external circuit is due to the movement of electrons. So externally we can see the current is due to the movement of electrons. And whereas the current in the P region is due to the movement of holes. And the current in the N region is due to the movement of electrons. So if you observe the external supply, so the current through the external circuit is due to the movement of only electrons, but actually inside the p-type PN region junction with the P region, the current is due to the movement of holes, and in the N region the current is due to the movement of electrons. The PN junction under reverse bias conditions. What is a reverse bias? When positive terminal of the battery is connected to N region and negative terminal of the battery is connected to P region, it's called as a reverse bias. So the holes in the P region, the holes are positively charged charge carrier and it is attracted by the negative terminal of the battery, whereas the electrons, the N region, are attracted by the positive terminal of the battery. Means they are moving away from the junction. They are not moving towards the junction as like in the forward bias. The majority charge carriers in the P side and N side are moving away from the junction. So what happens to the depletion layer? So the depletion layer, the width of the depletion layer will be increases. Means the opposition for the movement of the charge carriers is increasing in the reverse bias. Means the resistance increases. So the majority charge carriers are drawn away from the PN junction. And the depletion layer becomes wider and increases the barrier potential also. The electric field is increasing. Means the barrier potential is increasing. So due to this, the majority charge carriers are not able to cross the junction. All are moving away from the junction. So there is no current due to majority charge carriers. They are not crossing the junction. There is no movement of the charge carriers across the junction in the PN diode. They are moving towards the battery. So no current exists in the PN diode due to majority charge carriers. Means due to holes in the P region and electrons in the N region. But there is a chance for the current. Why? Because in P region there exist some electrons. In the same way, in N region there exist some holes. So the electrons are minority charge carriers in P side. The holes are the minority charge carriers in N side. These electrons and holes in the P region are repelled by the negative and positive terminal of the battery. Am I clear? the electrons are repelled by the negative terminal, the positive terminal of the battery. So the P side is connected to the negative terminal of the battery and N region is connected to the positive terminal of the battery. So electrons are repelled by the negative terminal of the battery and holes in the N region are repelled by the positive terminal of the battery. So they are moving towards the junction. Means the minority charge carriers are moving towards the junction. So there are a few thermally generated minority carriers in both regions. There are few thermally generated minority charge carriers in both regions. So the increased barrier potential enhances the flow of minority charge carriers across the junction. The increased barrier potential enhances the flow of minority charge carriers across the junction. And the generation of minority charge carriers depends upon the temperature. Means the minority charge carriers are very few and the current due to that minority charge carriers will be very less in the reverse bias. So the generation of the minority charge carriers simply depends on the temperature only and it is independent of reverse voltage. So to increase that current in the reverse bias, so we have to increase the minority charge carriers. The number of minority charge carriers must be increased. So when the temperature is constant, the current due to minority charge carrier also constant. But whenever the reverse voltage is increased or decreased, due to this region, the current is called a reverse saturation current. The current due to minority charge carriers is called as a reverse saturation current. Means if we increase the voltage or decrease the voltage, whatever be the voltage applied across the battery, at particular temperature, the current is constant. Current is constant, called as reverse saturation current. And this reverse saturation current is the order of microamps. And in some PN diodes, it is in the order of nanoamps also. Generally, it is in the order of microamps or nanoamps. So, to increase the reverse saturation current, we have to increase the temperature. Now, finally, the applications of semiconductor. First of all, the PN diodes are used in rectifiers, which are used in DC power supplies. So, semiconductors are used for rectification purpose, means conversion of AC to DC. And wave shaping circuits, such as clippers and clampers. Wave shaping circuits means in clippers as well as in clampers. And we use the circuits, means the semiconductor, in voltage regulator circuits. voltage regulator circuits and used in portable radios and TV receivers and used in science and industry, the solid state devices, space systems, computers, and data processing equipment, military equipment, and data display system, data processing units, computers, and aircraft guidance control assemblies. So these are the major applications of the semiconductor. So in this session we discuss the PN diode, the formation of depletion layer, and the biasing methods of PN diode. So PN junction is when P type is added to N type. P region is connected, means P type semiconductor is connected to N type semiconductor in such a manner that the crystal structure is continuous at the boundary is called PN junction. And the formation of depletion layer, actually in P region majority charge carriers are holes, minority charge carriers are electrons, and there are immobile acceptor ions, negatively charged acceptor ions, whereas in N region electrons are majority charge carriers and holes are the minority charge carriers, and there are positively charged immobile ions. When no voltage is applied to the junction, the holes are in the P region moving towards the junction and electrons in the N region are moving towards the junction, and they recombine each other. After few recombinations across the junction, immobile ions are created. The positively charged ions in N region, negatively charged ions in the P region are formed. And due to the difference, the concentration of the two regions, after few recombinations at the junction, the immobile ions are created, and if the holes in P region and electrons in the N region are tries to cross the junction, these will be repelled by the immobile ions existing across the junction. Means they are opposing, these immobile ions are opposing for further recombinations across the junction. Means at the junction there is a region is formed in such a way that there is a depletion of charge carriers. There is no chance of charge carrier in this region, called as the depletion layer or the space charge region. And in the depletion layer there is a positively charged ion in the N type and negatively charged ion in the P type, and the electric field is generated across the junction called as the potential barrier. Potential barrier. And this the width of the potential barrier is depends on the doping level. The doping level is high, then the width of the depletion layer is very narrow, and the doping level is less, the depletion layer width is wider. So this is the formation of depletion layer we already discussed. And there are two types of biasing methods in the PN diode: forward bias and reverse bias. When the PN diode is connected in forward bias, p-type semiconductor is connected to the positive charge, positive terminal of the battery, and n region is connected to negative terminal of the battery. So therefore, holes in p side, electrons in the n side are repelled by the battery terminals. Holes are repelled by the positive terminal of the battery and electrons are repelled by the negative terminal of the battery, and they moving towards the junction and recombine each other. Means they are entering into the depletion region. So therefore, the width of the depletion layer is decreases, means the resistance of the PN diode is decreases. So, and they recombine each other. The holes and the electrons are recombine each other. So here these recombinations takes place continuously. For each recombination of hole and electron, an electron will be starts from the negative terminal of the battery and enter into the N region. And in the same way, one electron can break the bond with break the covalent bond and enter into the positive terminal of the battery. When one covalent bond will be breaks, a hole is created, and that hole is moving towards a junction and recombine with the hole with the electron. So this process continuously happened. So if you observe the conductivity process, externally the electrons the current is due to the electrons, whereas if you observe the internal process inside the PN diode, there is a movement of holes in the p side and there is a movement of electrons in the n side. So the current is due to the movement of electrons as well as the movement of holes, and there is a electron current is existing as well as there is a hole current is existing. The total current is due to I, the current due to holes plus current due to electrons. So see the diagram. So this is the forward bias of the PN junction. So positive P region is connected to positive terminal of the battery and N region is connected to a negative terminal of the battery. So you can see in the slide there is a clear, it is clear that the depletion layer. So this is the depletion layer, positive and negative terminal of the battery. So see these white color circles are the holes, and here pink color these are the electrons, and here in P region there are minority charge carrier as electrons, and in the N region the white color circles indicates the minority charge carriers that are holes. And at the junction you can see the negative immobile acceptor ion in the P region and positively charged immobile donor ions in the N region, and this is called barrier potential. Electric field is generated from positive ion to negative ion. Electric field is generated called as barrier potential. This is also called as depletion layer. And here the PN diode is connected in forward bias. So P side is connected to positive terminal of the battery and N side is connected to negative terminal of the battery, and here the barrier width is decreased. See the holes and electrons are moving towards the junction. So electrons hole recombinations takes place across the junction. Now we go for the reverse bias. So PN diode is connected in reverse bias. P region is connected to negative terminal of the battery and N region is connected to positive terminal of the battery. Then the holes in P region and electrons in the N region are attracted towards the battery terminals. So see the slide. The holes are moving towards the negative terminal of the battery. Here electrons are moving towards the positive terminal of the battery. So what happens when the majority charge carriers are moving away from the junction? Means there is no current across the junction. There is no current across the junction. But actually it is not happening in the reverse bias. Is the current in the reverse bias is zero? No. It is existing. Very small current is flowing in the reverse bias. How the current is generated in the reverse bias? Is it due to majority charge carriers? No, not at all. Why? Because they are moving away from the junction. If any charge carrier is moving towards the junction only, there is a chance for the current flow in the reverse bias. So you can see the clear picture. The holes and electrons moving away from the junction, and the barrier potential is increased, means there is a heavy opposition for the flow of electrons and holes, means there is opposition for the charge carriers. Finally the resistance of the diode is increases. But here, in addition to holes in the p region, there are some electrons in the p region. They are minority charge carriers, and in the n region, holes are the minority charge carriers. And in the due to minority charge carriers in p and n side, they are repelled by the battery. Why? Because electrons are repelled by negative terminal of the battery. Holes in n side are repelled by the positive terminal of the battery, and they are moving towards the junction. And they enter into the depletion layer, and some recombinations takes place, and in the same way the electron entering from the negative terminal of the battery and enter into the n region, and finally reach the positive terminal of the battery. So this constitutes electric current. So therefore, in the reverse bias, the current is due to minority charge carriers. Is it more? The minority charge carriers current is more. It depends on the applied voltage? No. It is independent of the applied voltage. The number of minority charge carriers is only depends on the temperature. If the temperature increases, then the minority charge carriers also increases. Some covalent bonds will be break, and there is a possible for minority charge carriers in the PN diode in the reverse bias, and due to the minority charge carriers, some current will be generated. As we increase the voltage in the reverse bias, there is at particular time the current is equal to increases. The current due to the minority charge carriers remains constant. Even by increasing the applied voltage. Whether the reverse voltage is increased or decreases, the minority charge carriers, the current due to minority charge carriers remains constant. That's why it is called as a reverse saturation current. And the reverse saturation current is the order of microamps or the order of nanoamps. It is very, very less. Why? Because it is due to minority charge carriers in the reverse bias. Now the applications, there are so many applications. We discuss some of the applications as rectifiers in clipping clamping circuits, voltage regulator circuits, TV receivers, in science and industry, computers, data processing equipment, military equipment, and data processing units, and data displaying system. So these are the few applications of the PN diode. So this completes my session. Thank you so much.